Okay, so today we're going to be looking at quadratic functions. So first of all, let's define what we understand to be a quadratic function, right? Now, I hope that you all have your graph pages, because if you do not have your graph pages and you do not practice at home, then you are definitely going to be lost. And this topic, as well as construction, which we will do in the coming weeks, is a practical topic. So you have to actually practice drawing graphs, right? Now, I don't want to misguide you all because I don't know the full details of the education briefing from last week. Sorry, from yesterday when the Minister of Education addressed the public. But I believe that term 3, which is what's supposed to happen from next week, is going to be now from September to December. And the new academic year, which usually starts in September, is now going to start in January. And I believe they pushed the SEA back until then. So I'm not sure if CXC will also push the exam back till there, right? And if they are pushing it back to there, then there is a possibility that the exam might be a normal paper 2 exam, right? But again, we're not too sure as yet. Things are changing by the minute. So again, you want to be very much prepared, right? And in today's class, you will be learning how to draw a graph and also how to read a graph. And once you can draw a graph, you will be able to read a graph. And that's very important, reading off a graph and drawing a graph as well. You need to know both, because in the multiple choice, you could possibly be asked to read off a graph, or in the paper 2, if God forbid you will have one this time, you all will have to know how to draw a graph. So both of them are equally important. So you need to know how to do both reading a graph as well as drawing a graph. Okay, and in today's lesson, we are going to learn about both. Okay, so it's very important. That's why I said I'm not, although the exam so far we know it's multiple choice, I'm not taking that for granted, because again, things are changing by the minute, right? So I'm not sure if CXC will change their exam structure or change their exam date, but we don't want to be too, I don't want to be too shaky on that, because I want to do everything. I want to cover the entire syllabus. So at least when I know you are writing the exam, come what may, I know I can handle it, whether it's paper 1 or paper 2, or I have to write, or both. Okay, so let's start off with quadratic functions and defining a quadratic function. So far in our study of linear functions, that just basically means like simple functions and whatnot, we may recall that a linear function has a general form y is equal to mx plus c. And if you all could remember, when we did coordinate geometry, we met this here, and that is the equation for a straight line, right? And x and y are the variables here, and m and c are the constants. The variable meaning it doesn't change. Sorry, the variable meaning that it changes, and the constants remain the same. Okay, so x and y can basically assume any value. That's why they vary and they are called variables. However, m and c don't change. They are referred to as constants. Okay, we would have done all that when we did algebra and coordinate geometry and all of those things. So everything is tying in here. Okay, so a graph of a linear function is always a straight line with a gradient, which we know to be m, and whose intercept on the y-axis is c. And if you all can remember, when we did coordinate geometry, I told you all that the intercept is where the graph cuts the y-axis. Okay, so I hope you all could recall that. A graph or a curve. Oh, Marie, in maths, even if you have a straight line graph, it's still referred to as a curve. Okay. In some cases, some teachers refer to it as a curve. I sometimes, from time to time, refer to it as a curve, but yeah. Oh, wait, I totally misread that question, right? A graph or a curve. Both of them, a curve is a graph. A curve is a graph, so yeah. So another property of a linear function is that the power of the unknown is 1. So if we were to draw the graph of y versus x for the linear function, y is equal to mx plus c, the straight line will cut the x-axis at one point only. So this is a characteristic feature of a linear function. So some examples of linear equations are shown in the table below. So we have y is equal to 4x. So here we have the gradient being 4 and the constant, sorry, the intercept, which is c, being 0. The other one we have y is equal to 2x plus 7. So here the gradient is 2 and the intercept, which is c, is 7. Next one we have y is equal to 3x over 5. So the gradient here will be 3 over 5 and there is no intercept. Okay, that was just a real refresher here because we did all of this in coordinate geometry, and I did tell you all everything that we do is going to be linked. Okay, every chapter depends on the other one. So let's get into quadratic function. So we will now study a function in which the power of the unknown is no more than 2. This function is called a quadratic function. Its special features and characteristics will be explored fully in this section. We must first learn to recognize quadratic expressions. Okay, and I didn't remember telling you what a quadratic expression was, but let's read it still. A quadratic expression is one in which the highest power of the unknown is 2. So that, in other words, you see like how we have in the example here, we have 3x squared. That is the unknown there, and the highest power it is 2. Okay, so to the power of 2 basically. A quadratic expression in x has a general form ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. No, Sushmita, I will not. I don't think I'll be teaching until next year. I'm teaching until the exam happens, whenever the exam happens. I'm not sure exactly when the exam happens. So yeah, I didn't remember telling you what a quadratic expression is of the form ax squared plus bx plus c, and it does not have an equal sign. And however, a quadratic equation does. Okay, so quadratic expressions in the form x, for example, may take all of the following forms or the varying forms, right? So we have 3x squared plus 2x plus 5, and here we have a being 3, b being 2, and c is equal to 5. You all are supposed to be able to, you're all supposed to be able to identify where I'm getting these things from when we did factorization, right? Let's look at the next one, 5x squared minus 2x. So here we can see that a is 3, b is negative 2, and there is no c. Next one, we have negative x squared plus 4. A is therefore negative 1 because remember there is a 1 understood in front of the x, and that negative sign makes it negative 1. B is equal to 0, and of course, c is equal to 4 because b is attached with bx, and there is no bx. Once it stands by itself without a variable, then it's called c. X squared, so we have x being, a being, this is supposed to be negative 1, not negative 2, this is supposed to be negative 1. B is 0, and C is also 0. You all seeing that? Are you all seeing that? Okay, great.
Yeah.
So let's get into the important stuff, right? The things that will help you in the exam. The graph of a quadratic function. So what you have here, let me just let you all write it down for a while. Just write down this part I'm going to highlight here. So y is equal to x squared plus 2x minus 3, and it lies between negative 4 and positive 2. Are you all finished writing it down? Okay. You guys write down y is equal to x squared plus 2x minus 3 between negative 4, x and 2. That's all I write, right? Okay, so I'm taking it off now. Are you ready for me to take it off? You're still writing.
No, sir, don't take it off as yet.
Okay, who is Galaxy A10?
Let me.
Sandra, that's you?
Yeah.
Oh, okay. Okay, so I'll take it off, all right? So, are you all seeing the whiteboard? Yes?
Yeah.
Okay, great. So these here are the values for x, right? So what we are going to do now is construct a table of values. In maths, it's called a table of values, right? So you have x on the top, y on the bottom, right? They are telling us that the values for x lie between -4 and +2. Again, this just means the values lie between -4 and +2. So we are starting with -4. So -4, after -4 is -3, -2, 1, after 1 is 0, oh sorry, -1, and after 0 is +1, and then +2. Anybody confused about that so far? And these are -4, which is this -4 here, and this is the 2 here, right? And these are the values between them. Anybody confused as yet? Anybody want me to repeat anything? Yes, no? Okay, no problem. So these are the possible x values, right? And this is what y is. They are telling us that y is equal to x squared plus 2x minus 3, okay? So let's see how we are going to obtain our y values here. So when x is equal to -4, let's see here. We have y is equal to x squared plus 2x minus 3. So we substitute x is equal to -4 into this equation here. So we get -4 to the power of 2 plus 2 into -4 minus 3. Y to the power of -4, sorry, -4 to the power of 2 is 16. 2 by 4 is 8. A positive by a negative is a negative. And then, of course, we bring in the minus 3. So y is equal to, just a minute. Right, y is equal to 16, take away 8, take away 3. So y is equal
5.
to 5. Yes, correct. So when x is -4, y is 5. Yes? Any confusions there? Now we're gonna do the same thing. When x is -3, y is equal to x squared plus 2x minus 3. So y is equal to -3 squared plus 2 into -3 minus 3. So y is equal to 3 to the power of 2 is 9. Well, a plus by a minus is a minus, and 2 by 3 is 6, and of course minus 3. So 9 minus 6 minus 3 is 0. So when x is -3, y is 0. Okay? And you have to do this for all the values. So when x is -2, y is equal to x squared plus 2x minus 3. So y is equal to negative 2 to the power of 2 plus 2x minus 3. Y is equal to 2 to the power of negative 2 to the power of 2 is 4. Supposed to put minus 2 here. So this will give us minus 4 minus 3. So this here will cancel off, so you're left with minus 3. So minus 3. So I'm going to give you all 5 minutes to finish off the table, and I'll be calling some of you for answers, okay? Which last one, Felicia? This last one here? Okay, sure, no problem. So we have when x is negative 2 now, right? When x is negative 2, y is this y here. So we are substituting negative 2 wherever we see x. So y is equal to negative 2 squared plus 2 into negative 2 minus 3. So this will give us positive 4. This will work out to be minus 4 minus 3. 4 take over 4 is 0, and 0 take over 3 is negative 3. So that's why I got negative 3 here. All right, so you all have 5 minutes to work on the other 4.
So
Yeah?
I'm kind of confused because you have negative 2 squared plus 2 by negative 2. Where I get the other one from?
What are you talking about? This last one?
Yeah, because you have y is equals to negative 2 squared plus 2 by negative 2.
Right.
So I kind of confused where the other two come up.
Y is x squared plus 2x minus 3, you know, and we are using x is equal to negative 2. So negative 2 squared plus this 2 here into x, which is negative 2 minus 3.
Oh, okay.
Understand? Yeah.
Yeah.
Maria finished? Okay, good. So today we are only going to be focusing on the graphing aspect of this handout, right? Not the other stuff. The other stuff we will do that in another class. I want to make sure you master the graphs first. Because to plot any graph, you have to complete a table of values.
Okay, I'm finished.
Okay. Not yet, Marie. You don't have to plot the coordinates as yet. Okay, so let's continue then. So when x is negative 1, Marie, what did you get for y?
2.
Everybody else got that?
No,
What you got, Sanjay?
negative 4.
Okay, let's see then. When x is equal to negative 1, y is equal to x squared plus 2x minus 3. So y is equal to, sorry if the camera is jumping because my marker is hitting the tripod. -1 squared plus 2 into -1 minus 3. -1 squared is +1. A positive and a negative is a negative, and 2 by 1 is 2 minus 3. So y is equal to 1 take away 2, take away 3, which is -4. So Maria, I hope you identified where you went wrong. So let's see now when x is equal to 0. Y is equal to x squared plus 2x minus 3. So y is equal, sure, this one here, ma'am?
Yes, sir.
Okay, no problem. So when x is -1, for all the values, y is equal to x squared plus 2x minus 3, right? So we are substituting -1 throughout. So it's -1 squared, because that's x, plus 2 into -1 minus 3. So y is equal to -1 squared is +1. A positive by negative is a negative, and 2 by 1 is 2. And of course, you bring on the minus 3. And of course, you could use a calculator here, and you will get the answer to be -4. Because when you find the difference, you find the difference, which is 1, and you keep the sign of the greater number. So that's -1. And -1 minus 3, -1 minus 3. Here the signs are the same. And when the signs are the same, you add, so you get 4, and you keep the sign of the greater number. Right? Understand? Yeah, no problem. Okay, so when x is 0, so that's 0 squared plus 2 into 0 minus 3. So this will go to 0, this will go to 0, so you have left with minus 3. Right? What did you get for when x is 1, Desha?
So I do that one.
All right. Rihanna, what you got for that one? Marie, you got 0. That's correct. Yes, correct. So when x is 0 now, oh, what? Sorry, when x is 1, y is equal to x squared plus 2x minus 3. So y is equal to 1 squared plus 2 into 1 minus 3. So this becomes 1 plus 2 minus 3. So 3 take away 3 is 0. So that's why we get 0 here. Last part. When x is equal to 2, y is equal to x squared plus 2x minus 3. Y is equal to 2 squared plus 2 into 2 minus 3. Y is equal to 4 plus 4 minus 3. So that'll give us 8 minus 3. Y is equal to 5. Right? And that's our completed table of values. All right? You all okay?
Yes, sir.
Okay. Now, this working is not done in great detail in the handout, but it's there on the handout, right? So these values here, the -4 and 5, they make up our coordinates. The first coordinate, -3 and 0. Second coordinate, -3, -2, -3. Next coordinate, all of these here make up the coordinates, right? In our table of values. Okay? So we can call this A, we can call this B, C, D, E, F, G. Everybody okay? You all okay? All right. So let's get into a graph then, what we call a graph. So let me just explain to you. Can I take off this from the screen, the whiteboard?
So give me 2 minutes, please.
Sure, no problem. I don't want to be saying this man mixed with dog, but he's really Russian. Sorry for Russian people.
So go ahead, I took a pic.
You sure? I can wait or no?
Okay. Thank you.
Okay, no problem. All right, so let's continue then. Just one moment. All right, so let me stop sharing. This that you are seeing on the screen here, this is called a Cartesian plane, right? Where you see the coordinates here, okay? So you see on this side here is x. This is the x-axis. This entire line, the horizontal line is the x-axis here. Everybody okay with that? Yes? And this entire line going up here is the y-axis, okay? Yes, people? Anybody have any questions? Nobody has questions? All right. So again, when you are drawing your graphs, I'm gonna switch back to the camera now, right? So I'm taking on this working now, right? An important thing or an important fact to remember when you are drawing a graph is to look at your coordinates. So again, we know how the coordinates would look, right? You do a small sketch of the graph. Of course, you would use a ruler, right? And a pencil. You do not draw a graph in pen. You use a nice thin pencil. Make sure your pencil is a thin pencil. The reason being is when you have fine lines in the graph and you have to actually read off a point, if you use a fat point, then your graph is going to be a little off, slightly off, right? When it could be one tiny block accurate, it will be one tiny block inaccurate. Okay, So make sure you have a sharp pencil, or that those mechanical pencil would work very fine, right? So again, when you draw a graph on a graph page, you will label here X. Here will also be X. Down here will be Y, and up here will also be Y. Okay? Just remember the Y is on the top, right? And the X is on the horizontal axis here. So as you all can see, this is the negative side. Of course, 0 is in the center of the circle, right? Sorry, the center of the Cartesian plane. So let's look at the largest X value on the negative side. This is the negative side here, right? The largest X value is -4. So we know we can have 1, 2, 3, 4. Of course, negative, right? The largest positive value is 2. So again, 0, 1, 2. Now, when you are drawing graphs, the spaces between the coordinates must be the same. For the entire line here, for this entire axis, the spaces must be the same. I will show you about spaces just now. Right now, we're just going to plot a simple graph here. Let's look at the Y values here. The largest negative Y value, which is down here, this is the negative side of the Y axis. The largest is -4. So 1, of course, -1, -2, -3, -4. Right? Again, I am not using graph paper, so I don't know, my spaces will be inaccurate, but you have to use graph paper, right? The largest positive Y value is 5. So we know we're going up 1, 2, 3, 4, 5. Now, what a lot of students do, they see, okay, like how they have no other values besides 5. What they will do is put 5 right here. That's incorrect, eh? You have to go 1, 2, 3, 4, 5. Now, please pay attention to what I'm going to tell you all. Suppose we have a value like 100 here, right? You can't go up 1, 2, 3, 4, 5, 6, etc., right? Because you will never finish on time, right? And the graphic will run out, etc. What you have to do in that case, you could go up in either 5s or 10. So you can say 10, 20, 50, 40, 50, etc. Okay? You'll catch that? But if you are doing that, you can't go 10, 20, 30, 40, 50 on this side and then say 1, 2, 3, 4, 5 here. You have to do the same thing here. So you have to go 10, 20, 30, 40. Here has to be the same thing too. 10, 20, 30, 40, 10, 20, 30, 40, etc. Okay? It has to be uniform. Am I clear?
So I have one question.
Yeah?
Is it a 0 on the Cartesian plane, the 0? How come you not put in 0 here again? 0, 1.
Oh, sorry. I was just checking to make sure you were paying attention. Very good observation. Sorry, my apologies. 1, 2. I didn't make an error. I just was checking to make sure you were paying attention, right? Very good observation. So we are finished with our graph, but what we have to do is identify our scale. Okay, let me just show you all what I mean by that. If you all can see the graph paper on the screen here, right? On an actual graph paper, one block here, you're seeing the blocks, right? Let me just zoom in a little bit. One of this block here, are you all seeing it? Yes, no? Right, one of this block here represents 2 centimeters, okay? And since our values are very small, we can use one of this block here representing 2 centimeters, okay? 2 centimeters represents 1 unit. 1, 2, 3, 4, those are called 1 unit. So 1, it is increased by 1 unit. The 2 is increased by 1 unit, which is 3. 3 is increased by our next unit, which is 4. So each block here represents 1 unit. Okay. Of course, if we were counting in tens, so this 1 would have represented 10. This 2 would have represented 20. This 3 would have represented 30. Our scale, we will say, 2 centimeters equal 10 units. Everybody okay with what I just said? Everybody wants me to repeat it? Go on your mic and tell me, because I'm not seeing the chat on my screen right now. Anybody wants to repeat it?
Sir, I send you one on WhatsApp. Check and see if it's correct.
Okay, I'll try that just now, Marie. But anybody on have any issues with this one here? Want me to repeat it?
No, sir.
Okay. All right. Just now, Marie, I'll check that just now. Okay. So in our scale, we will say now that 2 centimeters equal 1 unit. You have to put your scalar. You have to put your scale, otherwise you're going to lose marks in the exam. So let's plot our graph now and see how it would look, right? Of course, I'll plot it here, and then I will show you all how it would look if I actually plotted it correctly, okay? So the first coordinate for A, when x is -4, so let's look at -4 on the x-axis, that's here. Y is +5. So +5 on the y-axis, that's here. You don't have to draw these dotted lines, right? Right, and you can pair a point or you can pair x, right? Either one will work, a nice point, or you can pair x if you want. It doesn't matter, right? When x is -3, that's here. Y is 0. So y being 0, that's on this line here. So that means it's this point right here. When x is -3, y is 0, that's right here. When x is -2, y is -3. So -3, y, they meet at this point here. So this is our point here. So this is A. This is, of course, B. This is C. Let's look at D. When x is -1, y is -3. Sorry, when x is, oh, -4. When x is -1, y is -4. So that's here. So that's right here. This is D. When x is 0, y is 3, -3, sorry. So that's right here. That's F. When x is +1, y is 0. So that's over here. That's G. And when x is +2, y is +5. So that's right here. Sorry, this was E, this was F, and this here is G. Right. So now we will take you can use a different color, right? You use a pencil, and you connect the points in a nice smooth graph. Right? So it's not art. Don't sketch a graph. It's supposed to be a continuous point, right? And you have to curve it. A lot of people go from here and they do that. Your graph is not supposed to have any sharp edge. It's a curve. It's supposed to have a curve, right? So you curve here, you're going back up, passing through this point here, and going here, right? You see, it was a continuous line, right? I didn't do this, and do that. So, and your curve looking like this, right? This is not art class. This is maths class. You have to draw a nice smooth curve, okay? If you are having problems drawing a curve, there is something called flexi curve, right? I can't spell it. I'm not sure if it's F-L-E-X-Y or F-L-E-X-I or probably a different spelling. But if you go in any stationery store or any bookstore and you ask them for a flexi curve, they will give you, it's like it's square, it's blue, and it's a long, it's like a straw, but it actually, you can place it here along the points and you can stretch it. It's flexi. Like them stretching the ruler, they have a flexi ruler, and then it's something like that. And you can actually put it along the points in the exam, right? And then just line it up, and then just take your ruler and of course draw it, right? But obviously not now, Marie. When the shutdown is finished, after April, you have to get that. But you don't need it right now. right? So that's not important. That's just if you are having serious problems drawing your graph. So yes, this is how your graph will look after you are finished, right? So let's just see how it will look professionally done on a graph paper. Right, so let me just input my values here. So y is equal to x squared plus 2x minus 3. And our table of values will be -4 to +2. Right, so this is how the graph's supposed to look, professionally done, right? No, it's not cheating, Maria. I'm not gonna do graph. If I use a graph paper, let me just show you how it will look. This is how it would look on the screen. It will be very dazzly, right? That's why I'm doing it online, right? This is how the graph paper would look, and you will not be able to see anything. I did try it before class started, right? And this is how it looks. Isn't that confusing, everybody? It will give you a serious headache. Yes, exactly. So that's why I'm doing it online, using a graph plotter, right? So this is how it will look professionally done. Of course, you don't have to draw this right now because it's on your handout that I will be sending for you all after I'm finished these topics, all right? But I will also send you all the link for this graphing calculator that I'm using, so you all could practice with it, right? And let me just show you how to use it. So reload. Let me just quickly show you how to use it. So this is where, this point here is where you are inputting your values. So you press here, and again, our they told us that y is equal to x squared plus 2x minus 3 in the question. So you're clicking here, this is x. This button here, the square with the 3 power of 2, that means 3 power of 2, so x squared. Of course, you just put your plus 2, and it's 2x, so you press back x again, right? And it's minus 3, so minus 3. And this is what the graph will look. And then you click these 3 dots here. You click table of values. The start value, they told us between -4 and 2. So -4, and the end value was 2, and you just press OK. And you could obviously zoom out, and this is what your graph would look like. Right? So when you are doing it at home, as practice, you can check your graph to make sure it is correct. Okay? I will send you all the link for this graphing calculator. Okay, but of course I'll send it after class. So can I move on? Just reading the chat. Oh, Maria, now seeing you say you send it on WhatsApp. Okay, very good. But you see, Maria, your graph has a point. So this, you see how mine is curved here? Yours have a point. Okay, so just be careful about that. Proper locks. Okay, so let's move on now. This is another image of the graph, how it could look, right? So that being said, I want to give you all a graph question to try. Okay. So let me write it down for you all. Draw the graph of y is equal to x squared minus 5x plus 4 that lies between -1 and 6. Try that question for me. Give you all 5 minutes to try it. And I will have some, but the first thing you have to do is obviously construct your table of values, right? That's the first thing you have to do.
Say your mic on, you know.
Sorry. My apologies. Good thing I didn't start to sing anything. Way boy.
You was like, whoop, 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 whoop.
Sushmita, if you can hear me, you need to WhatsApp me so I could send you the material, right? Everybody else, you can check your WhatsApp. I send the link for the graphing calculator.
Is it expensive?
What's that? If what expensive?
The graphing calculator.
No, it's a link. It's a link. You just have to click it.
Oh, I thought you meant a real graph calculator.
No.
I was gonna be like,
This is
you're gonna see.
GeoGebra thing that is actually really good.
Yeah, I know of them.
Yeah. Okay, can we do the table of values now?
Yes, sir.
Okay. So first things first, I'm going to call on some people to tell me the values, right?
You're calling me, I'm not finished.
Okay, so -1, 0, 1, 2, 3, 4, 5, 6. Okay, so when x is -1, can Shushmita tell me what is y?
$10.
Correct, 10. When x is 0, can Rihanna tell me what is y?
4.
Correct. When x is 1, can Felicia tell me what is y? When x is 1, sorry.
8.
8. How you get 8? No? Let's see. Y is equal to x squared minus 5x plus 4. So y is equal to 1 squared minus 5 into 1 plus 4. So 1 minus 5 plus 4. When the signs are different, you find the difference. So the difference between 1 and 5 is 4. And they keep the sign on the greater number. So -4 plus 4, y is equal to 0. Right? So you're telling the corrections. When x is 2, y is what, Vikash?
Sad and finished.
All right. Miss
I have it, sir.
Budu?
Yeah, I got -10.
No, Sandra, that's wrong.
Oh,
Mrs. Budu, what did you get?
Let him finish it.
All right.
this is not.
Okay, yes, Emily, you are correct. It's -2. When x is 3, Marie, tell me what you got.
-2. Minus.
-2.
It'll
Yes,
be
Marie, you are
-4.
correct. -2.
I don't know where I get minus thing from. I do something wrong. And I realize it. I do minus
All right.
minus
Hi,
10.
You get away there, Hima. Desha, what did you get for when x is 4?
Finish that one, huh? So I get 0 for the first one, not 10.
That's for this one?
Yeah,
You want me to do it for then?
yeah.
All right. You can tell me that. So when x is -1, it's -1 squared minus, this is -1 plus 4. So y, when x, of course, you can use a calculators here, right? It will help you out much faster. -1 squared is +1, and negative and negative is a positive, and 5 by 1 is 5 plus 4. So 5 plus 1 is 6 plus 4, y is 10. See where I went wrong, Disha?
Yes, sir.
All right. So when x is 4 now, anybody can tell me what is the value for y? Sanjay, want to give it a go?
Yeah,
Where you get?
yeah.
0, correct.
I
When x,
actually have that.
when x is 5, anybody can tell me what y is?
4.
Correct. And when x is 6, what is the value of y?
10.
35.
No, 10.
What?
So I'll do the last one and all two, right? Right. So y is equal to 6 squared minus 5
Yeah,
is
I had plus it. That was
plus. All right, so you see where I went wrong, right? 6 squared is 36, minus 5, 6, 30, a negative or positive is a negative, and of course plus 4. So y is equal to 36, take away 30 is 6 plus 4, y is equal to 10. All right. So these are our respective values for x and y, right? Now, of course, if you want to pull out the coordinates and have it like this, -1, 10, of course, 0, 4, 1, 0, 2, -2, 3, -2, 4, 0, 5, 4, and of course 6, 10. I used to do this as a student and call it A, B, C, D, E, F, G, H. And I used to look at this as opposed to the table. This for me looked better and I was able to see the values much easier, right? So I'm sure you all didn't reach the graph as yet, but let's just see here. The largest x value for the positive side is 6, and the largest negative value for x is -1, right? Similarly, the largest value for y is +10, and in the negative region is -2. So this could help us to determine our scale. In our scale, we can use our the scale. We can use 2 cm. Now we can't use 2 cm because the graph paper might be too small. So we can say 1 centimeter equal 1 unit, right? I'll show you what I mean by that just now. I'm going to show you all the graph paper. It's going to dazzle a little bit, right? Okay, now that's too much. I have a headache seeing that. So yeah, our scale 1 centimeter represents 1 unit. I'll show you what I mean by that now. Can I take off this from the screen or you all still taking it down and stuff? Okay, so I'm taking it off then. All right, so let's go on a table of values here. So let me just zoom in. All right, so our value, we still think like as x squared minus 5x plus 4. And of course, we put our table of values. It's between -1 and of course 6. And we click OK. And this is what our graph will look like. All right. Yes, people? Now I want you all to actually draw the graph, right? So I'm gonna give all a question now, and I want all to actually draw it, and I want all to WhatsApp the graphs on the WhatsApp group for me. Okay? I want to see every person who is online right now try it, and of course send it for me. If you do not have graph pages, you can use our file page then and try to be as accurate as possible. Okay? I'm going to give you a question to try. I'm going to leave this graph up here, but I'm going to give you a question to try now. And I want all to send me the graph. So let me pull up a question now. y is equal to x squared minus 2x minus 3. Also, x lies between -2 and 4. This is an actual past paper question, right? This is May 2015 I'm giving you all here to do. But just piece of it though.
Here, sir?
What's that?
Was the paper, which year is the paper?
2015.
Okay.
But I'm actually changing it up a little bit. Right, so let me see. Shushmita, you don't have a phone or a laptop? So what device are you using right now? Everybody can see the table, right? I want you all to copy it, complete it, and WhatsApp me the answers, please. Oh, okay. Well, in that case, you will just have to send me the values for your table of values then. So I'm giving you all 5 minutes to do this. This question is not too hard, right? And I want you to also tell me what scale you all are using, right? Oh. Yes, Andre, that's correct. The first thing is 10. I'm just stepping away from my computer, right? So I'll be back shortly. I'm giving you all time to draw this, right? So I'll give you an additional 10 minutes because this question seems as though it will take a lot of time, right? So again, first step you do is construct table of values. Then after you have finished with table of values, you have to construct your graph, make sure and put your scale, and then plot your graph, right? So I'll be back shortly. Anybody's finished?
Almost.
All right.
What is the second one? 6?
6. That's for -1?
Yeah.
Nah, try back again. Okay, Hema. And I'm looking at your wiki here. You are removing the 2 that is in front of the x squared. So let me just show you what I mean by that, right? Like in the example, the first one, right? Y is equal to 2x squared minus 4x minus 6. So y is equal to 2. You don't remove the 2. You're just replacing the x with whatever x value you are given here. So negative 2 squared minus 4 into negative 2, because that's the value for x, minus 6, right? So y is equal to 2, and negative 2 squared is 4. A minus and a minus is a plus. 4 2s are 8, minus 6. So now we can remove these brackets. So 2 by 4 is 8, plus 8 is 16, minus 6, which is 10. So that's why I got 10 here. With respect to the second one, y is equal to 2x squared minus 4x minus 6. Y is equal to 2 into negative 1 minus 4 into negative 1 minus 6. So y is equal to negative 2. A minus and a minus is a plus. 4 by 1 is 4 minus 6. So y is equal to negative 2 plus 4. When the signs are different, you find the difference, which is 2. You keep the sign the greater number, so it's positive. You don't need to put a positive sign here. And you bring on the minus 6. Right? So what else on their own? Just now, negative minus 6. 2 by negative 1, negative 1. Oh, right. Okay. This is where I went wrong. It's squared. So 2 by a negative 1 squared will give us positive 1 plus 4 minus 6. 2 by 1 is 2 plus 4 minus 6. 4 and 2 is 6 minus 6. Y is 0. So the value is 0 for there. Okay? I want you all to continue with this, trying to figure it out. We are not in a hurry to finish this, so I want you to take your time and complete it.
So
Uh-huh.
the last three coordinates for y, I get minus 6. So and again, a good graph.
Nah, that wrong. No problem, Emma. Okay, Felicia, would you like to share your values? Just a minute, right? Just trying to respond to somebody on WhatsApp here. Right. Emily, I'm now seeing your questions. Negative 6, 0. Okay, 10, 0. Negative 6. Okay, your last value is negative 6. Check back your values, Emily. After I see you get 12 on thing. Check them back. I'm just going to quickly erase this to do the other values. So when x is equal to 0, right? Y is equal to 2x squared minus 4x minus 6. Y is equal to 2 into 0 squared minus 4 into 0 minus 6. This will give us 0 minus 0 minus 6. So y is equal to negative 6. So negative 6 comes here. Let me do the other one time. When x is equal to 1, y is equal to 2x squared minus 4x minus 6. So y is equal to 2 into 1 squared minus 4 by 1 minus 6. So this will give us 2. This will give us minus 4 minus 6. So 2 minus 4, when the signs are different, you find the difference, which is 2. You keep the sign the greater number, minus 6. Now the signs are the same. When the signs are the same, you add. and you keep the sign of the greater number, so -8. Right? I'll give you all some time to do the rest.
Sir, I just sent you a message on WhatsApp.
All right, I'll check it just now. I'm just going to take your rule. Of course, if you all think you need extra classes in terms of like if you don't understand what I did today in today's class and you think you want another session, you all can feel free to join the other classes, right? But of course, if you are joining the other classes, you cannot miss your actual class, right? So let's just say, for example, I'm seeing Rihanna here. So if Rihanna is here, Rihanna, you can't miss your Saturday class, right? So it's just to have like an extra. So like you all will be in this class today. You wish to be in the class on Saturday. You all can feel free to join the Saturday class as well, right? From 1 to 4 p.m. And of course, I have the Monday class as well. The Monday class is from 9 to 12. Yeah, Marie?
Sir, I accidentally write 4 on my tables of values that I sent you, right?
Uh-huh. No problem. So let me see if yours is correct. Just a minute. Let me double check with mine. 0, 8. Check the last one, Marie. Well, you have 10, check by the last one.
1, sir.
When x is 2. Now here, man, check back that one. This is a 4. Yeah. Check by that one. Okay, so let's do the others. All right. So when x is 2, when x is 3, when x is 4. So when x is 2, y is equal to 2x squared minus 4x minus 6. So y is equal to 2x squared. In this case, x is 2, so 2 squared minus 4 into 2 minus 6. So 2 and 2 squared is 4. Minus 4 2s are 8 minus 6. So here, this is where you went wrong, right? So it's 2 by 4 now, which is 8 minus 6. So this will cancel off it, so let's get minus 6. Okay. So when x is 2, y is negative 6. Next one, y is 2 into 3 squared minus 4 into 3 minus 6. So y is equal to 2, 3 squared is 9, 4 3s are 12 minus 6. So y is equal to 2 by 9 is 18 minus 12 minus 6. So y is equal to 18 minus 12. And that take away 18 minus 12 is 6, and 6 take away 6 is, of course, 0. So 0 goes here. And of course, when x is equal to 4, y is equal to 2, 4 squared minus 4 into 4 minus 6. 4 4s are 16. 4 4s are 16 minus 6. 16 by 2 is 32, minus 16 is 16, take away 6. Y is equal to negative 10. Sorry, positive 10. Okay? Any questions there? Anybody? Okay, so let's see how the graph would look now if we were to plot it. So can I erase this? We'll leave it for a minute again.
Could you use it, sir?
Okay. So let's look at the values here. So the values for x, let's look at the positive values. The largest positive value is 4. The largest negative value is, of course, negative 2, right? Let's look at the values for y now. The largest positive value is positive 10. The largest negative value is negative 8. Okay, so we know it's not a big graph we draw it. So that being said, with our scale, we can say we can say 1 centimeter represents 1 unit, right? Of course, you have the big block on your graph page. This big block is broken up into 4 small squares, right? This whole thing here is 2 centimeters, right? This one of the block here is 1 centimeters, right? That's what I'm talking about. Okay, so here will be 1, 2, 3, etc. That's what this scale is telling you. Okay, so of course on our graph we know it would look, right? This is the y-axis, and of course this is the x-axis.
Sir, I sent the graph, okay?
Okay, no problem. I'll take a look at it just now. So yeah, this is how your Cartesian plane would look, right? So let's just go to our actual professional graph to see how it would look, right? Right. So this is our Cartesian plane here. Let's just put in our values. Right? So it's 2 x squared minus 4x plus, sorry, minus 6. And our table of values begin with -2 and they end with 4. Okay. So this is how our graph would look. Right? Let me check yours now, Marie. Okay, Marie, yours looks correct. Yes, it is actually correct. So very good, Marie. Marie, you want to share this graph in the group?
Sir,
Okay.
it kind of looks ugly.
That's fine. You have to share the first one and the second one that you drew. That's
Yes,
actually
sir.
what
You could share it, sir.
All right, no problem.
Okay.
I'll share them. All right. Rihanna, you could just message me. So your chat will come up and I will send it for you. Okay, the person who sent that last one, you can barely see the bottom of your graph. Rihanna, you can message me. Your chat will come to the top, right? As if you want to do.
Oh, sir, in the chat.
The evening class?
Yeah.
Serious? Hey, well, when you're big and large. You in Saturday and evening class too, Papa?
Yeah.
Well, all right. Okay, so yeah. Let me give you all another graph to try. Anyway, before we do that, I want to show you all something. And I want you to take it down, right? Draw it. Well, not draw it, but take it down. Okay. So let me just switch back here to the camera. And of course, by the way, here, as you could see in the on your screen, what I have on the side in here, these are your values for the table of values, right? So this is another way to check your graph values when you're using the thing that I sent you. Remember, I showed you how to do the table of values. This will actually give you the figures that you're supposed to get, right? So let's go back to here now. Let me just give you a quick note. When, and I want you to write it, okay? When the coefficient of x squared is positive, the curve has a maximum value. Sorry, minimum. And when
Yeah, alive, you're good.
Yeah, why?
You're not talking.
Yeah, because I know that I don't need to talk. I'll explain it after.
Oh.
So I hope you all are taking it down, right? Or at least taking a screenshot or something. No, you don't have to show all the workings in all the working in the exam. That is not necessary. So for the table of values, for the y values, you don't necessarily need to show the working, but you could, depending on how much marks they ask they giving you the table for. If it's for like 2 marks something, you don't need to show the working. But if it's for like 3, 4 marks something, just to make sure you could show the working. But I wouldn't take any chances and not show the working, because let's just say one of your values wrong. If they look through your working and they see that you just made a simple error, instead of losing a mark, you could probably get, sorry, instead of losing a whole 2 marks or something, you could probably get a mark for it or something. So the working is very important, but you don't necessarily have to show all the working. So yeah, but try to still show it. I always advise students to show all working. Okay, so let me just quickly explain this, right? So when the coefficient of x squared, remember, I told you all it's quadratics we are doing, right? And all of them are of the form ax squared plus bx plus c, right? Hence the reason we have things like 2x squared plus 3 minus 4 and so forth when we're doing the graphs, right? So when the coefficient of x squared is positive, the curve has a minimum value. And when the coefficient of x squared is negative, the curve has a maximum value. So here I have a table here, and you're seeing it? You're seeing it here, right?
Yeah.
Okay, right. Just making sure. Okay, so here I have a table with the minimum values as well as the maximum values here, right? It's just a comparison between the two of them. So here you can see y is equal to ax squared plus bx, and here is equal to minus ax squared plus bx plus c, right? So one is positive, one is negative. The minimum is positive, the maximum is negative. So what you all were doing before was minimum curves, right? And your curve, all of them looked like this. Of course, it doesn't necessarily mean that it looking exactly like this. Some of them could end up more here and up here, and this is just a general image. So if they ask you for the coordinates of the minimum, it's just where the bottom of the graph is that value there. Okay, you're following? So like, for instance, in the graph before, the value of the minimum, right? Let me just show you all quickly on the screen. Okay, you all seeing this the graph here? You all seeing it, right?
Yes, sir.
Okay, so if you all can see, this is a minimum curve here. This value here, which is -8, that is the value of the minimum. Okay, -8. Everybody okay?
Yeah.
All right. So I'm moving back now to the camera. Right. So here now we have what is called a maximum. So the value of the maximum will be on the top here now. It's just the opposite. Okay. So can I, yeah, no problem. So can I take this off?
Yeah.
Anybody else? Object? Sorry, anybody
No.
object?
No.
All right, so I'm taking it off. I have a smaller note to give you all. All right. This is called line of symmetry. Okay. Line of symmetry is any line that cuts a curve or any figure into two equal parts. So maths, to find the thing is x is equal to minus b all over 2e. All right. So if the question asks you to determine the value of the minimum or the value of the maximum, you're supposed to be able to know how to do that. Okay. If the question also asks you to draw the line of symmetry, you can't just go and draw a line of symmetry just like that, right? You have to actually determine the value of the line of symmetry. Okay. So to find the line of symmetry, it's -b all over 2a. And remember, they will give you it in the form ax squared plus bx plus c, or whatever value they give you for b, that is what you're using here. Okay, and it's minus b all over 2a. So let's just say, I just seen, right? Let's just say this value of b here was negative. Then it would be minus -b all over 2a. And this will change this entire thing, negative and negative, it will make it positive b all over 2a. Okay? A lot of students, if this is negative, they just put negative b and they don't change it to positive, right? They don't do it like this, how I have it here. Right, so let me just quickly take it off. Right. Can I erase this? Okay, so let me give you all a question to try now to do. So I'll give you all until 7:20 to do this question I'm going to put up on the screen here, right? Because I know you all are taking, I'm seeing you all taking a little while to do it. to try this question for me. And of course, you all can WhatsApp me the answers, okay? Hi, Marie, yes? Oh, can we not get a break today and finish early then?
Yeah, but if we finish early, I don't mind not getting a break.
Okay, yeah. So we can finish like around 7:45 8 and stuff.
Yeah.
After we finish correcting this question, I'll start correcting it and we'll finish about 7:30, and then I'll just show you an example with the maximum, and then we will end class there, right?
Okay.
Yeah.
Sir, what paper is that question? What year?
This is not in the anyone I sent you all. At least I don't think so. Oh yeah. This is from 2015.
Okay.
Yeah.
Mic on.
Can we correct now?
Sir, I sent you my thing, my graph and table.
Yes, sir, we can correct now.
Oh, I know seeing. It looks correct. Yeah, it looks correct. I'll actually work it out first. Just a minute. Let me form back the Zoom. Where is that? Okay, great. Join. Okay. So let us correct then. Let me just pull up the question here. Okay, so we are asked to complete the table of values, right? So we are given the x values, the y values. All right. I know some people messaging. I using my phone right now, so I would not be able to see WhatsApp messages, right? So -2, 5, -1. So we have to find out what this is. We got 0, 3, 1, -4, 2, -3, 3. We have to figure out what this is, and 4, 5. Okay, so we are given y is equal to x squared minus 2x minus 3. So we have to calculate when x is -1, right? So y is -1 squared minus 2 into -1 minus 3. So y is equal to 1. Negative and negatives are positive. 2 minus 3. So y is equal to 0. Okay. Next one. When x is equal to 3, y is equal to x squared minus 2x minus 3. Y is equal to 3 squared minus 2 into 3 minus 3. So this will give us 9. 2 3s are 6 minus 3. Y is equal to 0 again. You all got that?
Yes, sir.
All right.
I'll send mine in the chat fit.
Okay. All right. I can't check chat.
So-
I'm using my phone. Yeah, this here is my phone. So when I using the Zoom on my phone, I just can't check the WhatsApp. So that's 2 marks that I would have gotten right here for this, right? Next, let's see, plot the graph of y, okay, using a scale of 2 centimeters to represent 1 unit, okay? So one of the big blocks would have represented 1 unit. So let me just quickly check to see what you ordered on the sorry, let me see yours, Desha. Okay, it looks correct. Your table of values, let me just see the table of values, 0, 0. Okay, good, Desha, you can share it on the WhatsApp group, right? That is correct. So let me quickly pull up the GeoGebra calculator here. Okay, so we are given x squared minus 2x minus 3, and for our table of values, it's from -2 to +4. Okay, great. So this is what the graph's supposed to look like. Let me just compare it with what Desha sent. A is up there. Okay. Yeah, right. Okay, Desha, yes, your answer is correct. So you can share this, and I'll share it in the group then, right? If you don't mind. Okay, so yes, this is what the graph is supposed to look like. Everybody seeing that? You all got that for the graph? And the first value would be up here. The first value is up here. The second value is over here. Third, fourth, fifth, sixth, seventh. How many of your graphs look like this? Show by a raise of hands. Are you all there?
I didn't space out my coordinates, but it still look like that.
Okay, but your points have to be exactly over here and stuff, right?
Yes, sir.
Like 5 and -2 and stuff. Wait, just now. -2, sorry, and 5. Yeah, 5 is here. Okay, so let us see the other part of the question now. That's 4 marks just to draw this graph here. Sorry, 5 marks because you're getting 4 marks to plot the graph, and you're getting 5, you get an extra mark to connect the dots, right? So that's a total of 5 marks. So that's a total of 7 marks you're getting so far. The next, they're asking you complete the following sentence using information from your graph. So the values of x for which x squared minus 2x minus 3 equals 0 are. So what values you all put? Anybody? Basically, what I was asking.
1 and 3.
+1, +3, -3, what?
-1 and +3.
Correct. And how you got that?
I just look at the table of values.
The table of values, but the table of values won't tell you nothing. How you know is that? Oh yes, yes. When you say when x is equal to 0, okay, yes, the table of values is, you can use it as a table of values, right? But also you can use the graph. Okay, so this, you see where -1 is and where 3 is, the graph is cutting the x-axis at -1 and 3. Okay, you're seeing that here? It's cutting the x-axis at 3 and -1. Everybody okay? Any questions so far?
I got some.
I didn't hear you.
I got.
I still don't understand what you say, but all right.
I got.
Oh, you're good. Okay, all right. So yeah, this is another way of solving a quadratic. So far we have learned about factorization. I still have to teach you all completing the square, right? This is our next method, the graphical method, right? So remember when we did factorization, we got 2 values for x when the quadratic was equal to 0. We got 2 x values. So this is another way of getting the 2 x values. So the x values would be -1 and +3, of course. Let's see the next part of the question. The other part of the question says to determine the minimum value. So what is the minimum value here of this in this thing here? Anybody? -4, correct? Because as you all can see, it's -4 in the bottom here. This is the minimum here. All right, so this is where the minimum value lies. Let me see the next part of the question. The equation of the line of symmetry of the graph. Okay, so let me see if there's an option to do line of symmetry. Nope. No, there isn't a way to do line of symmetry here. But okay, let's just determine the line of symmetry. Remember, the line of symmetry is minus b all over 2a, right? So it's minus, let me just switch this. Right, it's minus b all over 2a, right? So it's minus negative 2 all over 2, and the value of a is 1. So this is positive 2 all over 2. So the line of symmetry is 1. Okay, people? So let me just quickly go back to the graph. Can I go back to the graph, or you all want to feed on this? Okay. So we know that the line of symmetry is 1. So as you all can see, and of course it's x is equal to 1, right? So our line of symmetry is over here, coming down here. Okay? So if you have to draw a line of symmetry, it would be right along this line here. So in the graphs that I've been receiving so far, I didn't see anybody draw a line of symmetry. Okay, but that's the line of symmetry coming right here, coming down here. Any questions so far? So that's
No, sir.
2, 4, that's 6, 7, 8, 9, 10. This graph's question is with 10 marks. So you see how easy it is to get 10 marks? And so let me see, I'm looking for a question with a maximum value here. Okay, never mind, I'll just give you all one. Okay, so I want you all to do this one for me. Plus 5x plus 3, and the domain try that one for me. You all ready to correct? Are you all ready to correct? Okay, so let's see our table of values then. -4, -3, -2, -1, 0, 1, 2, right? So when x is -4, y is equal to -2x squared plus 5x plus 3. So y is equal to -2 into -4 squared plus 5 into -4 plus 3. So y is equal to -2 into +16 minus 20 plus 3. Y is equal to -32 minus 20 plus 3. Wow, y is equal to -32. That will give us -52 plus 3. Y is equal to -49. You all got that? Okay. Rihanna, your mic is on,
I
right?
get 15.
You got 15. Now it's -49.
My mommy say you're wrong.
You
Oh.
forget to put this
-2. No, this is correct. -2x. This is -4 squared, which is 16. -20 plus 3. 2 by -32, -20. Yeah, that's correct. Let's see the other one. When x is equal to -3, y is equal to -2x squared plus 5x plus 3. Y is equal to -2, -3 squared plus 5 into -3 plus 3. Y is equal to -2. This will give us 9 minus 15 plus 3. -18 minus 15 plus 3. Let me just double check with my calculator. -18 minus 15 plus 3, -30. Anybody got that?
I don't understand
Yeah.
that thing you doing there, sir.
How?
Correct. The equation is -2x squared.
Minus 2x squared. It's just like what we was doing before.
Yeah, I totally missed the -2.
Oh, yeah. It's minus.
Initially, I did the same. That's why I couldn't answer you
Oh.
wrong.
Okay. But because I said I wanted to overclass earlier, I'll just quickly fill in the values, right? When x2, this will give us -4, -15. When x is 1 squared is +1, 2 by 1 is 2 plus 5 minus 3, and this will be -4. Correct me if I'm wrong. With 0, this will go to 0, so just let
-3 to, sorry, 3 to the next one, 6 and 5.
6 and
5.
all right, great. Yes. Okay, so let's see what the graph would look like, right? One moment. Okay, let's just refresh this. All right, so let's see. It's -2x squared plus 5x plus 3. And our table of values, they begin with -4 and they end with 2. Okay. So let's see our graph here. So of course, you will have to do a graph like this, right? Your scale will be 2 centimeters represent 10 units, okay? In order to get a graph looking like this. Okay, people? Right, so this is what the graph would look like. And as you all can see, 49 will be around here. It will be right here actually. Right, then -30 is here, -15 is here, etc. Okay, and of course, as you all can see, this is the table of values here that we generated. So any questions so far before we end class?
No.
Okay, so in Sunday's class, I'm going to continue with this, right? Okay, people?
Sir, Sunday classes be too early.
I know, but I can't do anything about that right now. It's just 2 classes again, and then that's it for Sunday class.
Check with Linda if they still have bio, because if they don't have bio, then you can switch to the evening class.
Oh, they have bio on Sunday?
They usually have bio at 2 to 5, and I think that was the reason why it was the morning class for maths. So I think Emily said they don't have any more Sunday bio classes.
Okay, well, I'll definitely ask Lyndon then.
All right, cool.
Yeah, so now I'll let you all know on the chat. Okay, goodbye, everybody.
So no Saturday class?
Yeah. But in the Saturday class, I'm going to be doing this exact same thing with you all. Because remember, your class is really Saturday class. So today class was just for the Wednesday class, and I'm going to teach you the exact same thing on, of course, on Saturday. Okay, bye, people.
Bye, everyone.
Bye.